Like for instance, or when I'll go with this maybe again when we go to the actual demos and examples. So let's go what we're gonna do today. So let me introduce myself. My name is Pawel Potacki, or if you speak an Eastern European language, is Pawel Potacki. Depends. Now I work for JP Morgan Commodities EMM technology team. Data visualization I've been doing for many years. Late 1990s and early 2000, I was actually at JP Morgan working with a specialized data visualization group that was called Data Visualization Group. And we did a lot of C++ and Java stuff for different desks. And right now, I'm using Python for a lot of my work. And data visualization, it's really been always important part of my work. In different aspects of it, in different ways, I can bring the applications to the users. Working in business environment is always a little bit different because you have the needs of others that you have to subscribe to. So data visualization is part of what people like sales and business tries to look at the different type of data and analyze it. So data visualization is always a big part of it. So what we're going to talk about here. So quick overview of what. So this is basically, I have a few slides and examples. I'm gonna be mix and matching those two. So a little bit of overview of the visualization, some UI toolkits. So this is for those who expected some sort of notebook, Jupyter notebook. This is not like that because we're talking about interactive standalone applications. So we need different approach to it. So I have a standalone files that you can run as applications. And I explained the Enaml because Enaml is the tool that binds all this visualization for me when I'm building those. And I explained a little bit what VTK does, Matplotlib, and put this all together, like how do I interact with this. So now, this is not in-depth tutorial about Matplotlib. That was something else. Yesterday was a good one. There's not an in-depth tutorial about Enaml or VTK, but we have just a certain amount of time, so I have to kind of glance through it, just show you what's possible. So then you can go and explore on your own. This is a screenshot one for VTK visualization. And most of the examples here, I'm not trying to bring any data that I have at work or whatever. It's just the stock examples. People who work in a bank understand that you can't really do that. So here, let's go. So why building visualization, interactive visualization? So this is something that I know there's a big effort now out there for web applications. There's great things like Bokeh that uses HTML5 canvas that can do 2D and 3D rendering with WebGL. People use Jupyter notebooks, IPython, right, to do this type of things. But this is more like, I would say in academia, it's a great thing. You can create the notebook with all the visualization. You can share with your friends, other colleagues with different universities, and so forth. In business, I can see the quants using that. Let's say do some modeling and then just sharing across their group or different groups. But in many cases in business, you really have to build standalone GUIs, standalone applications. And the effort always to build either long-term applications, and then you can build for 6 months, 1 year, complex UIs, or you can build like a simpler tools that you want to deliver to the particular desk. If anybody work on a trading floor and understands that there is a need of quickly creating some applications that certain people can use at a certain time. They have an ability to maybe slice and dice data. They don't really need huge effort. You don't need to put huge effort to it, but you need to put this together quickly, and you're going to have to deliver it. So there is always very strong need of interactive standalone applications. There's always, throughout my career, there is a switch between thin clients to thick clients to thin clients to thick clients. So there's back and forth. The Enaml, I'm going to talk about it, considers so as a thick client or thin client. Doesn't really matter. I mean, it's a great tool to create those quick UIs. So we need to, in business environment, create those quickly and high quality, obviously, and something that people can use. We don't really need to spend 1 year of developing some UIs. We need just a couple weeks, couple days. So we need the tools to put this all together. So this is the spiel about Python. I'm going to quickly go over this because all the Python developers here, so we don't have to really explain anything to it. What I want to say is that Python really exploded probably in the last few years. I mean, especially in business, I see it coming in big waves. There is a couple of good packages, and the really big strength of the Python is that it binds very well with other frameworks. So we can use C++ framework for really doing some intensive visualization or processing. And Python allows us to quickly just glue this and put this together and access this very quick way. In UI world, there's several UI toolkits. Let me just switch to that. I should probably mention here. Okay. There's several toolkits out there that very well live with Python. One of them is WX, so it's kind of older, but still in being developed UI toolkit that has a Python binding called WX Python, and there is Qt, which is a little bit newer, came from Nokia. It's open source, and I think it's a little bit better. It's newer, has some very powerful features. And the problem with the only drawback with this UI toolkits like Qt and WX is that the fact that they are multi-platform, so they tend to be big and heavy because they have to address Linux, UI native widgets, they have to address the Mac OS or Windows, so they tend to be heavy, but you always want to use, the good thing is that you develop the code that runs everywhere. So your Python runs everywhere, your Qt bindings run everywhere, so you write the code that runs on Windows and Unix and Linux, and because you're just using subset of the runtime libraries anyway at the time, so the speed is good, the size of installation might be a little bit big. So I really like Qt. We've been using Qt for a while over the WX. We started with WX, but we switched to Qt. It has a little nicer interfaces and has some nice features like slots and signals. And also Qt offers something interesting which is called QML, which is declarative language, which allows you to declare your applications in a simple file and then just run this, and this binds your widgets for you. If I switch Enaml, so I discovered Enaml a few years ago. I was working with the primary author of Enaml, who was from Continuum, named Chris Colbert, and Enaml kind of is influenced by QML, so it's also declarative language. So allows you to quickly create your declaration, your UI declarations. And it's, at this moment, it's, in a sense, only extension of Qt. So instead of, let's say, working in Qt, you can work with Enaml, and you know that you're going to have a Qt widgets underneath and access to most of them. The nice thing about the Enaml versus QML is the Enaml is Pythonic. It's Python. It's a Python extensions. So when you run the code, actually gets compiled to Python bytecode. So you can also debug the same as Python. So you can put your breakpoints there. And there's always a problem in the UI development when you have some sort of distributed, separated system that maybe your visualization, the UI declarations are in some sort of file, and then your controllers are somewhere else. Then how you put the breakpoints, how you're going to debug this. So nice thing about the Enaml is all Python. There's no additional language involved, no additional bindings. It's Python. Underneath there are some C++ widgets, obviously, but in a sense you work with Python. So you can work with the Python as Python object. You can extend it. You can overload it. You can overwrite things. You can put the breakpoints. And it's really very, very powerful language. Initially, I was a little skeptical about it. I came from the world when you kind of declare everything in a program yourself. But this allows you to kind of separate your views. So it runs, if you're familiar with model view controller, this one actually runs very nicely with that, meaning you declare your views in Enaml. Now we're going to show some examples in a few minutes. So this is some snippet. I don't know if anybody can see it, but we'll go through the code. And and has some very powerful features like dynamic scoping, like layout management, like binding with the atom objects, which I'm going to explain what it is. So it's really very friendly. It's easy to learn and very powerful. You can create the dynamic applications. So the certain parts of the UI can be dynamically created based on some sort of action. So it's easier than just maybe programming this in a Qt per se, right? So maybe I should bring some simple enamel file just to show. I should have PyCharm here. So can I make this bigger? Sorry, I don't think I can make this much bigger. I think this is like the simplest example here. Actually, well, let's go to enamel examples. This enamel examples are part of the enamel distribution, so it's just easy to. I don't know if you can see, but basically this is your enamel, or maybe just make it even simpler. This is probably the simplest one you can have. So basically you declare your UI here. You declare main functions. So enamel has something called enamel dev. Enamel has, like I said, it's Python, but it has its own keywords and attributes to make it a little bit different, right? So enamel def, it's like your definition, equivalent to def for Python function definition, and you have attributes. And then basically what you do here, you just lay out your tool, your UI with declare your components. So in this case, we have just a couple of components. We have a main window. We have some sort of message, which is an attribute, which can be always manipulate. We'll show that later. And then we have a sort of container, which think of it like some sort of box. Inside that container, there is something called label, which it's just a text and just a message. That's it. So very simple, nothing to it. Okay, so we're going to go a little bit more into details later. Is there any questions so far? Yeah?
How do you run it?
Oh, good question. I actually wanted to go to, so there is two ways to run it. Let me actually show you. So you run it, there is with Anaconda, there is a command distributed with enamel. It's called enamel run. So I don't know if you can see it on the ball. It's enamel. I don't know how to make this bigger. Maybe if I can make this terminal bigger. Preferences. Window. Where's the font? Oh, it should be able to make this bigger. Anyway, so there's a command. It's called enamel run. And then basically, you run your enamel file. So enamel-run space. So this is like a wrapper that provides the enamel provides for you to run the enamel files. And then that assumes that you have that main file in it, and that will just execute that main. So if I run this is like a little demo I want to talk about a little bit later. That's when I was actually creating some datetime components. So I'll show that in a second. But basically, that's it, right? And there is also and another thing. Most of the examples that I have actually I run it from the code, from PyCharm, that are you can bootstrap the enamel. I'll show you how to do it. But basically, you can either do enamel run, or you can do the bootstrapping in your code. And what I'm going to do, actually, I'm going to run another example file, which I'm going to use it.
It's all on your GitHub, these examples?
That GitHub that I showed you, yes, everything is there. Oh, let me go back, yes. Oh, no, no, no. The Enaml examples are part of Enaml distribution, so you can also get it from GitHub. Okay, so Enaml, the only tutorial examples are interesting. So you go to GitHub too, and you look for Enaml, you search, Google it, very easy, and then you grab this whole distribution, and there's an examples folder, and you can run through them. This whole bunch of them. What I want to do here is, I want to run this editor here, which is very useful. I want to show it to you. So it's Enaml run. And then I have something called live. Where is this? I want to bring it up because I want to talk about this as well. Okay, so basically it's simple, Enaml run. Now, let me just switch here just to kind of continue my thought, and I will go back to those things. Now, Enaml versus QML, so like if somebody wants to wrestle, what do I want to use? Do I want to use Enaml or QML? This is a snippet from QML file. It's also very similar, like you see. It has like a window, it has some menus, bars, buttons. It's very similar to Enaml. It follows the JSON syntax. But the problem with this is that it's not Pythonic, meaning you run that in a Qt environment, and there's a JavaScript engine behind it that interprets this, renders, allows you to render widgets. So it's a little bit, it obviously comes from Qt, so you can say, well, it's a big effort behind it, but it's not really Pythonic. I don't think that's like if you're a Python developer and you're working with Python, then you just really definitely want to have an Enaml. The nice thing about the QML is because it comes with the Qt, it supports all the widgets that they have, everything out of the box. Enaml is building up the widget set. So there's a huge number of widgets right now. Most important ones that you can create the visualization or UIs with it, like buttons and layouts and stuff like that, but doesn't have everything. And sometimes there's things that maybe you want to tweak it a little bit. I found myself going into a little bit deeper level into Enaml to maybe get handle of the actual Qt widgets from the Enaml, and then maybe just modify it if I wanted to. But all that should be gone, because all that should actually, I should talk to developers on Enaml, and just that should be probably exposed at some point. So it's growing. Maybe it's not growing very fast, but I hope it's going to grow faster. That's why I'm giving this talk. And once the bigger community builds around it, then definitely we can maybe request more support from widgets in Enaml. But as a programmer, as a Python developer, you really want to stick with Enaml. It's very easy. It's declarative like QML, but it's Enaml. So you can put the breakpoint. I can actually show that in a second, and so forth. Enaml offerings. So again, if you go to Enaml, if you Google what to Enaml website, you find there's some sort of documentation there. There's a whole bunch of widgets that they support out of the box of the Qt. The most important one, like labels, combo boxes, date selectors, pop-up views, buttons, labels, stuff like that. One of the great thing for creating the visualizations and UIs is docking layouts, which I'm going to show later. And one of the important things for me was really, okay, I can use Enaml, it's fine, but I really need to make sure that I can create dynamic interfaces. Now, if I press some button, some action happens, I want to pop up some interface that can be built dynamically for me. And that can be done with the things like include, like looper, like condition. So there's additional features built in Enaml that allows you to do that. There's also style sheets and templates. I'm not going to talk about that. This is something that you can then use to spice it up your views. There's also some timer deferred codes, which I'm actually talking about. Timer, I have a timer example. And so it's a rich offering, allows you to really build rich UIs out of the box, right? So maybe what I should do is, before I switch further, maybe run some examples. And I'll maybe come back to it as well. So for instance, here, if you go to PyCharm, I have my couple of examples here. Let me just show you how to bootstrap this in a code. So let me just find like a simple example. Let's say demo. So I don't know if you can see, but basically it's just a couple of lines of code to bootstrap your Enaml application. So you import Enaml, then from Qt you print Qt applications, because that's what you need for the main UI thread, And then the trick is, so the trick with Enaml is that because it's a Pythonic, it's Python, but it has the Enaml extension. Most of the UI IDE, they don't understand the Enaml, what Enaml is. So somehow, like, you need to make it, tweak it. Maybe I use PyCharm, so you can actually add the color syntaxing, or PyDef in Eclipse, or IntelliJ. But it still doesn't understand it, so sometimes you get all these errors. But you need to have that, because Enaml, it's separate file in a sense. So you need to do this with Enaml import. So you need to import your object, your class, whatever from Enaml with Enaml import. So then you can use it in your Python code. So I have some examples here. And I'm going to just comment this guy out, and then comment this guy out. And dynamic. And then you just basically create your application and call your main function. So I'm importing the main function. So which one is that? Mplot demo dynamic here. So I'll go a little bit more details later what I do here. Right? I just want to run it. Just want to show you that I've built this UI here. So this is my main method here that I'm calling that extends the window. So I want to have a window to start this with. And then I have some sort of container, which is the box in which I'm going to put some components. In this case, I have a matplot container, which contains the matplot canvas. And then you have a couple of buttons and stuff like that. So I'm going to run this. And I think that's going to go underneath somewhere. Yeah. So this is sort of Matplotlib embedded in Enaml, right? So I'll go a little bit later on what details what I'm doing here. I can refresh this data set. I can have the toolbar. So this is the toolbar that comes with Enaml. With the Matplotlib. You can kind of access this. This uses the Qt backend. So as you know from other talks and Matplotlib talks, they have several backends. Here we're using Qt backends. You can just change just change the location of that toolbar, or you can just get rid of it. There's some config file for which I use popup. So this is another Enaml widgets called popup view, and then I have some sliders, some stuff, so I can kind of play with it. So the whole idea for me to show you is the interactivity of how to interact easily with Matplotlib or VTK with Enaml. So the Enaml allows me to build these UIs, put these components all over the place, and then I can hook myself through the different events, which I'm going to show you, to underlying components like canvas. Like this is I'm manipulating the figure of Matplotlib here right now. So this is one of the demos. And the code, let me just kill it. The code itself, it's maybe a little bit at first overwhelming, but it's very simple. It's just Again, I'm using this attributes. I'm using the container. I'm going to go, actually, let me go and simplify this talk a little bit and go forward. So this is, before I go to, so this is what I wanted to show you here is that VTK, what's VTK? So VTK is a very powerful OpenGL-based object-oriented framework for visualization. It does really heavy-duty visualization on surfaces, or three-dimensional, four-dimensional, volumetric. You can slice it, dice it, do whatever you want with it. It's really powerful. It's been around for 20 years at least. And it's been progressing. There's new releases all the time. I was mentioning this in the beginning with 6.3. Just came out, so it's really, really actively developed. It's maybe a little niche, meaning that it's really complex to maybe use. But with Enaml, we can maybe make it easier. So Enaml offers I was talking to Chris when he worked with me at JP Morgan at some time, to actually include this VTK canvas into the Enaml. So Enaml offers this VTK canvas widget that basically takes your rendering engine that contains your rendering objects. Well, I'll show you how this works. And you can then bind yourself through Enaml tool at any point of that visualization pipeline to kind of change that. So we have the VTK, we have a VTK widget, and everything. The VTK is a C++ engine, but has a Python bindings. It has a Java binding, has some other bindings, but because of the bindings with Python, it really makes it easier to actually use VTK than you would use with C++, because you kind of almost interactively can do your visualization and change it, and different aspect of it. Unlike in C++, when you have to compile, maybe some bugs, deploy, and stuff like that. So Python actually makes it very easy to actually go and kind of allows you to play with the VTK on a deeper level. So this is the VTK we're going to talk about. And another one is Matplotlib that has been known for many years as well. There's a lot of talks about Matplotlib everywhere you go. There was a good one yesterday. Huge amount of different type of plots and charts. It's really overwhelming. There is big use of it in notebooks, like the Jupyter Notebook, but what I want to show you is how to can actually embed it in your user interfaces, user applications, GUI applications. And for that, we also, Enaml provides a widget for it called MPL Canvas. And that, because Enaml is Qt based, so therefore we're using the Qt backend. And if you attended the talk yesterday about Matplotlib, at some point there was a mentioning this object-oriented way of doing the Matplotlib. So therefore we actually extracting here the objects, so things like figure, like axis, that then we can manipulate through Enaml. So I'll show these examples again. And again, just what I was mentioning in the beginning, all this is available in Anaconda. Just get it. Except the VTK, you usually have to install it separate, but everything is there. So Matplotlib for the Matplot visualization here, Pandas if you want to get some data in, NumPy, Enaml. Hopefully that's going to get updated with the examples that I have today. Atom, which I'm going to mention again, the Enaml and Atom kind of live together. Enaml actually can control your models through Atom, which I'll explain in a second. And the Qt for version 4.8, I think at this moment is in Anaconda, but I'm sure if it gets updated, everything gets updated along. So why Enaml is so powerful? Why is it so good? Because it offers this dynamic bindings with your model. You don't have to really write a lot of code in order to modify something. It uses this Atom object, which is optimized C++ backend-based object that you declare certain arguments in it ahead of time, so he knows how to compile this properly, and you specify them almost like a strict type. So basically, if you have some sort of member, you say it's int, or if you have some other, it's maybe string or something else. So it kind of allows you to kind of precompile this and optimize it for speed. But the most important thing is it allows you to this bidirectional connection between your model and your UI. So you can have a UI that can manipulate your model, your visualization, and on the other hand, you can change your model visualization, changes your model, then maybe some thread changes your model that changes the visualization, right? So there's back forward. And so Enaml and Atom makes this powerful. And you can do the same thing with Qt. You can write this using signals and slots. But this one makes it much easier. I mean, in many cases, you just want to just quickly do this UI without just going deep into writing a lot of code. And again, like I said before, it's because it's Pythonic, you just can build your own libraries, and you can just add things to it that they can reuse your application. So one thing I'm going to do is I'm going to show you a couple of examples. For instance, here in this slide, let's say I wanted to create the new slider. The slider is kind of useful, right? You want to slide some data, you want to slice it and dice it, and in here you have slicer control. The slider itself, let me just bring this code. It's probably be better. So I have something. So in examples, when you download it, something called slider. So there is actually a slider component in Enaml, but it's just basically a slider with like I was just showing you the demo actually here. Let me run this again. So the slider here that comes with Enaml is that little slider, little box. It doesn't really have anything. It has just a little widget that you can slide. You don't have any information that you maybe add to it, right? So it's very simple. But let's say I want to have a little nicer. I want the slider to be a little bit deeper and have more information, right? So let me run another example in VTK. Which I think is, so let me, I don't know which one is that. Actually, I have this here, hold on a second. Let me just forward this, and I'll go back. Let me run this multi-windows view Enaml. Okay, so this is how, VTK. So this is my example, and I'm going to run this. So I'll show you now how do I maybe want to have a nicer slider side that actually does something else. So I have this VTK visualization here. And see, this is the slider components that I've just showed you in a code that has a little bit more. So I want to have a container that controls maybe labels. So I have a minimum value, maximum value. Maybe I want some values to show. So I'm extending the slider with that piece of code. So now if I slice this, if I go and I can slice to the visualization here, I can actually see what's going on, right? So here, the code for this, so let me just kill this. Again, basically, because it behaves like Python, I can just write my control, override container, and inside this container, I can stack my components, which is a slider. Then I want to stack some labels, and I want to lay them out appropriately. So, and then I can use it as just another component. So I don't, and these attributes that I'm exposing to outside world, right? So things like info label, like what's my text for minimum, for maximum, or current, right? So that it's all dynamically binded through my outside world, and which is here. I can see this is, I'm going to go through that again. See, this is my slider controls. So instead of slider, I have a slider control now that I provide minimum value, maximum value, slider value, and so forth. So I can build these components to kind of spice it up my visualization. So I can take a stack component like slider, I can wrap it into something nicer, right? So that's one aspect of it. Let's go back here. This is probably not in the right order. Here, so I was talking about the enamel and atom. So the idea is that you write your enamel, declare your code, and then somehow you need to bind it with your model. So in the middle between your enamel and your code, your model stands the atom. You actually, your model can extend the atom, or you can have an atom that, you know, changes in atom will modify your model. And it can go back and forth. And there's a specific syntax that enamel use, which I'll show you in the file. So basically, if you do assignment, that means it's just a simple assignment. You just assign the value to your, maybe label, to your text, to your label. Now, this is like a redirection to the right, so that changes in your UI, let's say in your slider, the value of slider changes, and then it sends it to your model. The other way around, you can do it, which is you can update, maybe some thread updates your model, and then it updates UI, so now you attributes on your UI, so this way it goes from right to left, so that flows, changes from right to left. And then bidirectional updates, so that means whatever I change, so basically those two together are this. So this one basically changes in one, changes another one changes this one. So they both go back and forth. And there is also double column like this that you can actually perform some action. So maybe there's some additional pop-up you want to, when you click on something. And so so this is very kind of interesting, the way that it's designed to allow you to provide that flow. This is interesting. So, and I have it here. So Enaml, when you download Enaml from the website, it's actually included in the tutorial. It's this. This is your live Enaml editor. That if you want to kind of build your own, quickly mark up your own UIs in Enaml, you can use that. And it live, meaning if I write something here, it just evaluates and tries to. Just put my glasses a second. No, so let's say I put label. Nice for text. See, I have a label here, right there. So you can quickly build some, mock up your UIs with this editor. You know, another label. So we have it 2 labels now, and so forth. So you can put your own components. You can test all the components that are with Enaml, even yourself, your own components here. You can maybe write some model, just hooks it up and makes it a little bit more difficult. This is very tool. It's included in the tutorial. It's basically the same. Yes?
The syntax highlighting, is that automatically included in PyCharm? It looked like you were using PyCharm and the syntax.
PyCharm?
Yeah.
No. So this is what I mentioned before. So Enaml, because has that Enaml extension, is really not recognizable by anything, right? But things like PyCharm or some other editor allows you to add. So in what I did in this PyCharm, I just created another file mode called .enaml, and then I just entered there, and I just went and add some syntaxing to it. So colors is there. The color syntaxing is there. There's another Sublime Text. Everybody uses Sublime Text. Enaml actually has, on the Enaml website, you can download the Sublime Text color mode, so you can drop it to your Sublime Text library, so it automatically colors nicely your file. But that's about it. It still doesn't. I cannot put the breakpoint yet in an Enaml file. I have to actually import PDB and set the trace in order to kind of get into that. I can do that because it compiles into a Python code, but editors don't understand that yet. So this one thing, a big ask of. I'm going to mention that at the end. That one of the big asks for community or for the users is to, if you want to make it this more usable and reach more audience, we need to better support in IDs like PyCharm or stuff like that. So you can actually integrate it nicely instead of just tweaking yourself. I mean, Sublime Text has it, but it still doesn't understand this is the Python. So there's no, this dot in code completion. It doesn't understand that I type push button dot and it doesn't know what's going on. Unlike in Python, I can do date time date dot and I can see what members of that date are. So this still it's missing. It's kind of annoying, but we need more support, more community behind it. When people start using it more, then I'm sure either somebody's going to come up, or I was thinking of doing this for PyDev, then I switched to PyCharm. I did it in PyCharm, but I'm new to it. I just did the color highlighting. I didn't do any syntax. That probably have to go deeper a little bit in the code itself to do it, because you need to reparse the file and understand what's there and stuff like that. But this editor, the only drawback to this editor is using Scintilla, Qt Scintilla port for the editing, for the text editor. So this doesn't really include, I don't know why, Anaconda does not really include that. So you probably, unfortunately, won't be able to run it, this example, even if you download my code, unless you get somehow the Qt Scintilla from somewhere, or build it yourself. Actually, building is very easy. Just download it, and it takes 5 minutes, because once you download, Anaconda provides everything you need to compile the Qt. So you have headers and you have libraries and qmake. So you just like qmake, make, and install, and here you go. So it takes a few minutes really to build it. And then you can use this live editor, which is great, because I can really show you something very cool. So for instance, I can go and I go to tutorial, Enaml tutorial, and I can go to maybe layouts. I don't know, widgets. That's this guy. Oh, this maybe it's too much. Something simpler. Form enamel. Oh, let's get that form. So basically, I probably just can take this and just see and just what do I do? I don't need all that. Just need the content. And just copy and paste here. And I hope this worked. It didn't work because this is, oh, here you go. So here we have a couple of examples. So basically you can get that right into the live editor and kind of play with it right away. And it's all live. So see changes here. So this is Enaml. So again, let me recap this. It has great features, a lot of widgets, a lot of controls. It's easy to use, dynamic binding with your model. So I recommend if you want to quickly create some nice UIs, you want to grab that. And this live editor, again, it's great for mocking up your UIs quickly. You need this Scintilla package, but that's pretty much it. Nice thing about UI and Enaml, the feature that probably I like the best is this docking system. So it uses this docking pane and docking area and dock items that you can put your controls in it, and then you can move them around. It's like Visual Studio C++, some other stuff that contains the same visualization, the elements. So you can, and there's layout. First of all, I didn't mention the layout. Layouts automatically are done for you, or you can apply the constraints using the VBox or HBox, a combination both two, so you can lay them in a horizontal or vertical way, or just kind of lay them together. So for instance, this one here, like I have, let's run some example for that. So something called, I have this Matplotlib example, and let me just run this quickly. So I'm going to comment this out, and I'm going to run this guy. So it's right here. All right. So here is some sort of VTK, Matplotlib visualization of some random data. But as you notice, I have actually docking here. So I can actually have my docking components. So I can lay them out, have multiple ones here, have one control, one maybe something else. So it's really, really interesting and very nice if you want to create some rich visualization with the dockings, because you can put them together. You have a controls on one side and some UI visualization windows in another area. So the docking, it's really powerful and it's really nice. Works very well. I'll go back to the other example I had with VTK, if you remember. That one has actually more. Oh no, this one is actually a very simple one. This one has only 2. And you can kind of put them a different way. I can add them here. Let me run the one that I ran it before. Canvas wrapper, Windows, this one. Yeah, so this one, for instance, uses this 3 windows, 3 docking areas here, right? You can dock them like this, makes maybe too much. And then now because of the resolution, so this is my controller here. I can maybe put it here somewhere, hide it. So it's underneath there. So anyway, so what I'm trying to say is here is that with this docking layouts, it really brings your visualization to life, because you can put several windows, several views on the same visualization in different places very easily with just dock items, and then you just can link them together in your code, and it makes it much more richer and nicer visualizations. So that's your docking area. So it's very simple. It uses vsplit layout. So you have a vertical split between dock item on the top, and there's another horizontal split on the bottom. So you have 1 on the top, 2 on the bottom, horizontal. So vertical, vertical, and horizontal, horizontal. And then you can put them all together the way you want. And the users can actually move them around. There is the ability to save this as well. So that's pretty cool. Another very important feature is to include dynamic components. I'm going to show this in a second. Now this is what I was showing you before, that multi-window examples. Again, 3 different visualizations with the different places. Control bar, control. So this is like a typical application. If you're in the business, you want to do some UI for the user, you want to make sure that you put this visualization in those nice layout, and you give them some control so they can run it, and you can maybe visualize it, slice it, and dice it, and so forth. And this is, again, how I bootstrap it. So this is something I was talking about before a few times. Let me rehash it again. So there is a command called enaml run. So you can run enaml run your enaml file. That it assumes you have this main in it. So for instance, this live editor. Here, it has to have a main in it in order to be able to run with Enaml run, right? So you have that, and or you can bootstrap in the code. I was showing this again. You just import Qt application and Enaml, and then from Enaml with Enaml imports in the context, you use import main or something else. It doesn't have to be main. It could be anything. The nice thing about the bootstrapping this way is actually you can pass the arguments into your Enaml file. So for instance, I can pass, in this case, I have an attribute defined in my main called custom title, and I'm passing this as a custom title. So I can pass the arguments. So if I would create like a UI, GUI UI for the users, I probably would have a Python file that bootstraps this with me, and maybe they can pass some arguments on the command line and stuff like that. So this is a little bit better, I think. So that's one thing. All right, before I go to more into maybe how to now hook this into the Qt, is any questions on Enaml? I mean, it's really easy. You can get your examples, run it through. It's a declarative language, all the components all together. So let me move to how do I hook this into the Qt? I mean, to VTK. So VTK, it's like I said, it's very powerful visualization language, and it's you probably don't see much of talks out there about it, unlike like Matplotlib or Pandas. It's open source as well. Everybody can use it. It's a little bit harder to use. It's harder to understand maybe, but it offers much more powerful visualization capabilities than anything out there, I think, in open source. And there is a simple pipeline that you create in VTK. Oh, this is like, I would just try to show you the VTK class index. It's so huge. There's like hundreds of classes. It's very overwhelming. But at the end, everything kind of comes back to the very simple pipeline. You input your data, then run it through the data mapper. Then you do some data processing, maybe filtering, scaling, some transformation. Then you create an actor. There's a notion of an actor. So each element is an actor. Could be a light, could be it could be a bounding box, could be a surface. That's an actor. And then, for instance, I have an outline actor right here, and I have an actor which is data actor. And then I stick this to renderer. I can optionally allow me to add camera and action, so there's different type of interactions. But basically, that's it. So this is your pipeline. And anywhere in that pipeline, we can actually, the data flows through the pipeline. Every time you render, it renders all the pipeline. So you can actually hook yourself into the pipeline, maybe in a filter level, or scalar level, or some transformation level, to change that through your UI and then re-render it. So then, therefore, you have those interactivity here. So let me run some code for this. So for instance, the good one is, maybe I should run a different one. There's extract. So there's some geometry extraction here going on. I'm going to run this. Yeah. So this very simple visualization. And again, I'm kind of hooking myself here into the visualization pipeline. So in my settings, maybe I want to change the radius or shrink factor of these little cubes here. So I can make them bigger. I can make them smaller. So I don't know if you can see that. So again, the whole idea of this talk is to how to build this visualization interactively. It will be, if I didn't have this interaction, then I would have to maybe go to my code, change it by hand, run it again, and see how this looks. Go again, change it by hand. That's kind of tedious, obviously. Or maybe I should have to write another, I don't want to write like a dedicated application for it. I mean, it's just a simple visualization, right? Some data sets. So Enaml actually allows me to do it very quickly. allows me to show you the code, just hook myself into this visualization pipeline and just quickly modify it. So this is just an example, but you can think of anything else. Here I have maybe an additional radius of these spheres that intersect here, and it's really simple to use, very fast. It's really cool, and the code. So, and again, I'm using some ducking here. So let me see. So what's the code behind it? So again, I don't know if you can see very well, but I'm using the duck items here. But what I'm trying to say is this is my VTK canvas. This is the guy that renders this geometry, and I'm declare here. There's a pop-up that you saw that when I popped it up, I have a couple of things in it. Label. This is my sliders that I was the shrink factor I was modifying, right? So you can see here, I was using this syntax, which is bidirectional connection, but I don't have to actually do that. I could say something like this. I could actually have a different syntax here. I could say this, just to give you an example, and then, but that's just what comes in, but then I need to send it out. So then I say value here, and then in the action I say, you know, this guy. Value. So that will be pretty much the same. Now, notice there's something called non-locals here. So the nice thing about Enaml has something called dynamic scoping. So meaning that I actually declare this controller here somewhere, right, in that item. But then I don't really, I need to pass it around. And I can declare this a bit earlier at some point somewhere in my Enaml file when I'm building it up. And then I don't have to really pass it to this pop-up view, the pop-up view that pops up when I press this button, right? So here, when I press that button, and just pop up this config pop-up that says show, and I don't pass anything else here, but through this non-locals dynamic scoping, I can actually get to that controller, so I don't have to really pass this around. So it's a very nice feature of Enaml, this dynamic scoping. So I can get to that. And then this control, here we have this render controller into which I'm popping up this view, this canvas view, this VTK canvas view. And that comes from extract model. Just want to show you how this is done in that model. Extract model, yeah. So this extract model now that I was building to control this visualization contains a couple of attributes or properties. One of them is the shrink factor, and I declare this to be float. So again, the atom you have to kind of pre-declare these guys, these properties, attributes ahead of time, so he knows how to optimize compile it into your into the atom object. And there is something called so basically, usually you know what you want. You string, you want float, you want some other stuff, but sometimes you don't. Like this is like a generic object. I don't know what it is. So it's interesting because there's two things you can do that. One thing is you can do the value. Value is very generic. So this data actor is obviously some sort of VTK object, VTK class. I don't even know. I mean, I know, but usually you may not know what it is. So you just say generically value, and there's will automatically find it for you what it is and bind it and makes it work. Or you can have, there's another call, if you actually know what it is, let's say you exactly know what it is, it's a VTK polymapper class, you can say typed VTK polymapper class. So there's exact bind, he knows what to resolve it right away. The bottom line is that we declare those variables here, and I'm building my model here. So this is like a stack example here. There's nothing really into it. There's a visualization pipeline going on. And what's more important is this class here, this render view controller. So this is something that I came up with. This, you can look through the code. I'm not going to go to small details, but this allows me to kind of create that renderer. And basically, this guy here it's part of the examples. You can find it. And basically allows me to kind of have some actions there, like maybe different movement of joystick or mouse or stuff like that. So this is very generic. The idea here is that, and this maybe it's a duplication. I just did it to kind of explain it, but as you see, I did it almost twice. So like the shrink factor is in both places. But what's here is that how does Enaml know? So how does my UI knows that I was changing my radius or my shrink factor, and actually something happened, right? So the thing about the Enaml atom is that it knows that when its members are modified. So you can catch that. You can catch that in action. So basically here, you do it two ways. You can do something like underscore observe shrink factor. So underscore observe. So when the compiler compiles it, it knows that underscore observe, and anything after that, it's your property. So it's a shrink factor, right? So every time I'm changing the shrink factor from my UI, this is going to happen. This code is going to execute. So now I'm capturing this, and I say, oh, my value changed. So let me, and obviously when I build the geometry, I kind of expose certain components to it, like geometry, like outline, like filter. And once I have that exposed, then I can also go and say, oh, now my shrink factor changed. Let me just modify that geometry with that new value and just call render. And that's it. So I have my component, I have my model that exposes this members. When they get modified, they just modify the underlying geometry or color or scale or whatever you want, and you just re-render. So therefore, you have that dynamic visualization. So let me run another example, maybe. This is, okay, let me just go through this because I know how much time we have. Okay, we still have some time. Okay, so again, we can hook ourselves to any point in the data pipeline visualization in order to modify it, right? And you can do, again, you can do slicing and dicing. I'm going to run this demo in the end. You can change the scaling, resolution. All of this is from UI through the atom model into the visualization. And there's a whole bunch of visualization here. For instance, let me run this VTK sample grid view enamel. So there is an example in VTK. You just can run it directly. And the nice thing about this is that because VTK Canvas, you provide the renderer, and most of the examples in VTK, when you download it, they just create the renderer. So they create all these actors that have all these different transformation and data maps. But at the end, they create the actors, they stick to the renderer. So all you have to do is just get that renderer and stick it to the canvas. So I can run this example. I forgot what it was. Sample grid view. OK. And so this one is this. The nice thing about it is I said, OK, so obviously you can run this as is. But it's not really interactive, right? It's just, what is this? Okay. Let me just run it again. For some reason, didn't run. I hope this is going to run because I'm not sure if I have a data in right. You know, I don't have a data in right place. That's OK. Let me run. Unless something happened. We can run the other one. VTK surface view enamel. Let's try this. VTK surface view run. I hope I don't have to restart this. Oh, yeah. The other one didn't run because I guess the data was in the wrong place. So here is another example of a stack enamel, VTK applications, and it's very static, but it's really, it can very quickly, I can hook it up to it and just change maybe scaling and change some resolution of the data. Again, it's same idea. You're binding your own, you're binding your UI into the model that controls your geometry or visualization flow. So, and you don't have to really worry about much because everything is wired dynamically under the hood. So you have to just worry about modifying the components. Let's run another one. Oh, we run this one. Let's run this. Let's run this one. This is a nice one. So this one is in a different folder. This one is in a VTK lib folder. And you run this VTK surface demo run. So this one, that's really nice because I hope to explore this a little bit farther into a little bit bigger visualization. In here, we have some sort of surfaces, and we try to hook up yourself. This is all the same thing. So I'll show you the code in a moment, but I've hooked up a little bit more components to it. So things like maybe changing the color map, you know. Everything is, so basically what I do is I have a list of color maps and I pick it up one and I stick it into the, my pipeline. At certain level, certain point of the pipeline, I manipulate the color map. And then nice thing about this that I have also the slices. So if I want to slice the data, I can maybe run the slicer here through the data, as you see this little. And I can take that data. This is part that is missing in this visualization. I can project that slice into two-dimensional chart. So I can hook here, let's say Matplotlib, and every time I slice this, I can take that. In fact, I do that at work many times. We have some structured data, term data, or volatility surfaces, or something like that, and you want to grab that from the surface, and you want to slice it through and see what happens at each stage. So therefore, then you combine three-dimensional visualization with the two-dimensional projection, right? Because charting, it's always better in 2D. You can do some 2D charting in VTK, but that's not going to look good. So, so this is, again, very simple hooking. And okay, I can change maybe background of the color. You know, it's not very nice. So anyway, so this everything here is interactively controlled through Enaml. Let me move a little bit faster because we have a few more minutes left, and I just want to show you a couple of things. So this is this. Now, Matplotlib. So there is a really big interest of Matplotlib out there, and in the end, most people use it in notebooks. I want to use it in interactive visualization. So there is a way to do it. There is still some missing pieces. So I want to talk to the authors maybe later. But in the end, that's your pipeline. So you have your figure. You add the subplot that gets you access. Then you configure your access. And then you maybe color bar or some lines, so thickness, all that stuff. And then basically you add your data to it and just stick it to the figure canvas. The figure canvas is actually part of the MPL canvas on Enaml. So all you do is just create those. And almost every example that is out there, like in a Matplotlib website, you can modify very easily to run through these examples with Enaml. So for instance, let me just, so you understand that. I mean, most of the people are familiar with Matplotlib, so this is kind of simplified pipeline, but that's what we try to do here. Again, you can, there's an MPL canvas that comes with core Enaml, but you can extend it as you did with VTK, with something else. You can have, like in this example, I have something called VTK MPL container. Basically what it does, it just puts a couple of things together for me. So every time I don't have to just redo it. So I just stick it in the visualization all the time. And let me run through a couple of visualizations here. So let me run through this grid data demo. Let me just close all this. So if you run this on your own, I have this mplot demo run.py that I just comment out a couple of examples here. So basically all you have to do is just comment out and run the one that you want. So which one are we going to run? We're going to run grid data. Oh, no, this one actually is in a different place. This way. And I have two of them. Let me run this guy. I guess we can run this one. OK. So again, this is your Matplotlib embedded in Enaml. And that I've hooked up some UI components to it to manipulate this. This is the stock example. You can find it on the website and just kind of manipulate. The one thing I've done it here is maybe, let's say, I want to change the color map. Everybody hates this rainbow color map. So, well, this one. Or maybe I like pink. Yeah. Anyway, so I actually, all these color maps comes with Matplotlib. I just have a little utility somewhere there that extracts all this from it and then just sticks it into the Enaml components, and then you just can get it. And so it's just example of how easy this can be, right? And here I have some configuration as well. Maybe I want to, this is, again, there was a static example. There was a certain number of counters, certain color map. What I did is I just, OK, let me just make it a little bit more interactive. So I wanted to quickly change the color maps, and I want to maybe change the number of counters, right? So, so I can do that as well. And it's all it is basically what I do is, what I'll show you in the code in a second, is I hook, again, my properties of my model into the UI. And then every time you change the UI, then I go into that pipeline that you saw, and I modify some properties of the figure or of axis, and I just redraw. The only thing you have to do is just clear it every time. Otherwise, it will compound the visualization on top of it. So here is basically the code. I don't know if you can see, but basically it's, again, simple main that extends the window, and this whole bunch of labels. And this is my object combos. One of them is, this is the config pop-up that I pop it up in order to get your slices. And then there's a color map here. I get my color maps. And then, obviously, this is just the UI. This is your declaration of UI. You notice also there's a lot of these examples I actually mix and match. And it's another proof of this, that this is, Enaml can be great. And it's like Python. So I just basically stick my Python code in it, right? The class grid mode, right? Now, the only disadvantage of this using in Enaml is that you have really less control of debugging, right? Or maybe the editor doesn't support all the features, right? So for instance, if I wanna, I'm gonna show you in a second, but let's say I have this, another keyword. So I showed you this one way to notify the member, how this in Enaml when it's notified through UI. Another one is through this observe. So, and here I can actually stick together several ones. So number of counters, color map, number of points. So basically what I do is every time one of these attributes gets notified, this whole function gets rerun. But basically what it does, it's basically replots the data, right? So And I'm using this deferred call. This is very important if you actually want to use real-time visualization in real time, because you want to make sure that every time the thread updates your model, the model then has to obviously update your UI. You want to do it on the main UI thread. So that deferred call allows you to do so. And this is my draw labels. So I'm redrawing the labels. And I'm here redrawing my data. So this is my data. And then basically, I just rerun the data with a number of points. And that's it. And I just redraw it. So now, every time I change the UI, this code executes, redraws the data. And then you have this dynamic visualization. Let me run another example. Let me run. I don't know what was this one. Again, all these examples are there. They're all working, except you might have to modify a little bit the location of the icons. Oh, here, this is actually the same thing. Except this one. Oh, so this one has, no, this one actually doesn't work. This one is just the same thing. The other one is when it has all this dynamic. So this one was just an example of having the really static visualization, and the other one is just how do I spice it up by modifying things, right? Let me run another one. How about something that has like a real-time update? So so there's again example from the website. It's a scatter plot. And again, I want to make this a little bit more dynamic by hooking up my UI into the pipeline of this drawing. So first of all, I can refresh this easily, right? So this is pretty good performance. Then we have, I can change my titles, right? And then I can change my data points. And then maybe change the radius. So again, it's how dynamically I can, hook my UI through Enaml with the underlying. And the code itself is very simple. And then there's another one I have here, which is very similar, but what's nice about it is this has some sort of. So this is, I guess we ran over time. Sorry. Let me just run this one. What the heck? This one has. You have to look to the examples. This one has the. This one has automatic threading. So this is almost like your dynamic animation, right? So start, stop. Anyway, it's time to finish. So conclusion. So I hope I showed you how to easily manipulate your visualization with Enaml by hooking up certain components. And the future, like I was talking to someone here, more Qt widget support, maybe PyCharm other IDs support, extend maybe within the backends. That's it. Thank you.